Hi everyone, today we're going to be going through a review video on the 102 quiz, adding and subtracting expressions in one-step equations. This video is not the exact questions from the quiz, but it is very similar, so a great resource for you to review if you are trying to retake that test and improve your score and understand the material a little bit better, because this is a really important skill that will follow you through math. All right, let's start off with questions number 1 and 2. Those are based on the concept of combining like terms. And remember, you can only combine like terms, so combine, add, or subtract, if your terms are alike. That means they either have the same variable with the same exponent, or they don't have a variable at all. The numbers are a constant. When we look at our expression right here, we need to simplify that. So do as much math as possible to get it as simplified, as basic as possible. First thing I notice is parentheses. I remember order of operations always tells us to look at the parentheses first. When we look at our parentheses, can we actually do what's inside? Can we add 15y plus 3? No, because they're not like terms. The 15 has a y, the 3 does not. Same goes with our second set of parentheses. We cannot subtract those because the -5 has a y, the 8 does not. Therefore, there are no like terms I can combine. When that happens, the next thing that we should look at to see if we can get rid of these parentheses is anything being multiplied by them? Because if so, we can use the distributive property. Well, when I look at my first set of parentheses here, there is nothing on the outside that needs to be multiplied and distributed. When I look at my second grouping, my second set of parentheses, all we have is a plus sign. And that positive doesn't affect your signs at all. Therefore, there is nothing that needs to be distributed. When this happens, we can essentially drop the parentheses and just combine like terms. If we look through this, I'll go ahead and rewrite that in case that makes it a little bit easier for you to see. Now we need to combine any terms that are alike. When I'm doing this, I just start at the left and then work my way through to see if there are any matches. First off, we have a 15y. Are there any other terms that have a y with them? Yeah, there is, right here. Be careful though, the reason I like to circle mine is because I can include the sign with it. The sign in front of the number belongs to it. That tells you whether it's a positive or negative. It tells you whether you're adding or subtracting. In this case, that negative or that minus, got synonyms here, interchangeable, tells us that we are taking 15y minus 5y. That's important because otherwise you might get the answer wrong. 15 minus 5 is 10. We have 10y. Now, do we have any other sets of like terms? Yes, we do. We have our constants, so our plain numbers. Right here, we have a positive 3, and then here we have a minus or a -8. Both of these numbers are constants. They don't have a variable, therefore they can be combined. Remember your rules for adding and subtracting integers, so adding and subtracting negative numbers. When you have opposite signs, so a positive 3 and a -8, subtract the numbers, and then your answer will have the sign of the larger absolute value. So 8 minus 3 is 5. 8 has the larger absolute value, and 8 is negative. Therefore, your answer will be a negative or a -5. When I look right here, is there anything else we can do? Nope, I cannot subtract them because they're not like terms. Therefore, that is our simplified answer. That is our expression. All right, question number 3 on the quiz uses combining like terms like what we just did, but it also has the distributive property, which we did talk about. When I see my problem and look at those parentheses, I always look to see if I happen to be able to do what's inside. My first set here, the 9z and 8 are not like terms, can't combine them. The y minus 10, not like terms, can't combine them. Second thing I look for is, can we use the distributive property to get rid of your parentheses? Out front of this first group, Nothing is there, nothing needs to be distributed. However, when I get to my second group, we have this subtraction sign. Remember, subtraction, negatives, those are synonyms. That right there needs to be distributed because that minus means we're subtracting, we're doing the opposite. It is going to change the signs, it is going to change what we do to everything inside that group. I'm going to go ahead and just write my first set of parentheses down because that doesn't change at all. I don't want to lose it. But now I need to distribute that negative to everything inside. Distributing means you multiply. So if we multiply a negative times a positive y, your rules for multiplying and dividing integers, if they have the same sign, your answer will be positive. If they have different signs, your answer will be negative. Well, here we have different signs, a minus and a positive y, meaning it is a negative y. Here we have a minus and a minus 10. So the signs are the same, which means your answer will be positive. That minus times a minus, negative times a negative is a positive. Now that we've used the distributive property and we know that our signs are all correct, we can go forward with combining like terms. All right, what like terms do we have here? We have a 9z. Are there any other like terms with a z? Nope. So we would just write it down. I like to do all my variables first to make sure nothing's missed. Right here, oops, I should change colors, shouldn't I? We have a minus y. Any other y's? Nope. Just bring it down. We have a minus or a -8. Any other constants? Any other plain numbers? Yeah, positive 10. That means these guys can be combined. Remember those rules of adding and subtracting. If their signs are the same, you add it and it stays the same because you're continuing down the number line. If their signs are different, you subtract and take the sign of the larger absolute value. Our signs are different, -8, positive 10. That means we're going to subtract. 10 minus 8 is 2. 10 is the larger absolute value. 10 was positive, which means our answer is a positive 2. Anything else we can do here? Any other like terms? Nope. We are done. That is our answer. All right, second half of the quiz gets into solving one-step equations. Equations, the reason the word is solve is because we actually can find the answer. We can completely finish this problem and figure out what our variable stands for. Because the whole reason we have a variable in math is it represents an unknown value. We don't know what number should go there. Here, that's what we're trying to figure out. We're going to figure out what number that variable really stands for. First one, we have m plus 12 equals a -5. I personally like to draw a line straight through my equal sign because when the problems get a little bit harder, it helps me separate the two sides so I can focus in on what I need to do. Our whole goal here is to solve for our variable. By doing that, we're trying to get our m all by itself. So the m needs to be the only thing that's over here on the left. Therefore, we need to get rid of this plus 12. The way that we move something across that equal sign over to the other side is by doing the inverse, so by doing the opposite. What would be the inverse of adding 12? Subtracting. So to move that plus 12 over to the other side, to get it to cross that line, we have to do the inverse, which would be subtracting 12. Because it's an equation, that means both sides are equal. In order for us to keep them equal, in order for us to keep them balanced, whatever we do to one side, we have to do to the other. So if we subtract 12 over here, we also need to subtract 12 on this side. Now that we've identified that, let's do the math. This m is not a like term. I'm not subtracting the 12 from it. Just bring it straight down. Positive 12 minus 12 is 0. That's why we do the inverse, because by doing the inverse, it zeroes it out, it cancels it out, and allows it to only be that variable. Now we have a -5 and a minus or a -12. Remember our rules for adding: if their signs are the same, you add them and keep the sign the same because you're continuing down that same side of the number line. They're both negatives. Well, I can just add them. 5 plus 12 is 17, and they stay negative. Now, if you wanted to double check your work because you're like, ooh, I really don't want to mix this up, I'll show you on this one how you can do that. Now that we know m is -17, you can substitute, you can put this in for m and see if you really get the answer of -5. So -17 plus 12, and we want to see if it really equals -5. That'll tell us whether we did our math right or not. -17 plus 12, their signs are opposite. So my adding rules tells me to subtract, take the sign of the larger absolute value. 17 minus 12 is 5. 17 is the larger absolute value, and 17 is negative, meaning our answer would be -5. There we go. We got what we were supposed to, so we just confirmed that we didn't make any mistakes, and m equals -17 is our answer. All right, let's try this one out over here. V minus 2 equals -10. Same thing, draw that line to help you visually separate it. Our focus is on the V. We want to get the V by itself. Therefore, we have V minus 2. What would be the inverse? What would be the opposite of subtracting 2? Adding 2. We get that to the other side by doing the inverse, by doing the opposite. We are going to add 2 to both sides of the equation. Now let's do the math. That V is not a like term, just bring it down. -2 plus 2 is 0. Those cancel out. -10 plus 2, opposite signs, so subtract. 10 minus 2 is 8. Take the sign of the larger absolute value. 10 is larger, 10 is negative. Therefore, our answer is a -8. And V is all by itself, so we're done. All right, let's just try a couple more here. 6 and 7, the last two questions on your quiz, are also solving equations. 1/4 x equals -10. We draw this line right here down the center to separate it. We want to get this x all by itself, but it's being multiplied by a fraction. We're still going to be doing the inverse. We're still going to be doing the opposite. Now, with fractions, the opposite of a fraction is to take the reciprocal. The reciprocal is when you take your fraction and you flip it. So you flip-flop the numerator and the denominator. So that would be the inverse of the fraction, is multiplying by the reciprocal. So if we take the reciprocal of 1/4, that would be 4/1. And we are going to multiply both sides by 4/1, because whatever you do to one side, you have to do to the other. All right, this one, I want to go ahead and prove to you why that works. So let's fully do the math here, but you might get to the point where you just know that if it's the inverse, it cancels it out. But remember, when we multiply fractions, we go straight across. So 4 times 1 is 4, 1 times 4 is 4. And then if we simplify that, 4 divided by 4 is 1. So we are just left with one single x, which is exactly what we wanted. So that is why multiplying by the reciprocal works. All right, over here, -10 times 4/1. Well, to multiply fractions, we need them both to be a fraction. Remember, you can rewrite any number as a fraction by putting it over 1. Multiply straight across. -10 times 4, -40. 1 times 1 is 1. What can we simplify that to be? Yeah, just -40. And x is all by itself, so we're done. All right, last but not least, -18 equals -3y. Draw that line down the center. This time our variable's on the other side. That's okay. It just means that is where our focus is. Because if we're trying to get the variable by itself, whatever number or numbers are with the variable are what you got to move to the other side. You got to get it away. Right here, don't let that negative fool you, because that is not y minus 3. We are not going to be adding. It is -3 times y. Because remember, one of the ways we can show multiplication is by putting a number and a variable side by side. Therefore, what is the opposite of multiplication? The inverse of multiplication is division. We are going to divide both sides by -3. When I do my division here, I use that fraction bar to show division, just because I think that's easiest. We'll divide both sides by -3. When we're multiplying and dividing, remember, if the signs are the same, your answer will be positive. If your signs are different, your answer will be negative. When -18 divided by a -3, negative divided by a negative would make it a positive 6, positive 6. And then -3 divided by -3, when you divide something by itself, it just equals 1. Once again, that means we're left with one single y, which is what we're going for, because that tells us our answer is 6. All right, now, if you watch this video to prepare for the quiz, go for it. If you watch this video to earn another attempt on the quiz, the code word that you need to email your teacher is bananas. So email your teacher, tell them you finished the video, the code word is bananas, and then we can get another attempt unlocked for you, okay? If you have any questions, make sure to let us know. Bye.